Okay, I guess we'll get started. We're a little bit early, but it should be fine. My name is Matt Graham. I'm here to talk about Etsy and how we are changing our architectural foundation using continuous deployment. I'm a core engineer at Etsy, and I'm coming at this from the perspective of someone who works on this, is involved with making these big infrastructure changes on a regular basis, and getting to see how continuous deployment really helps doing that, helps make it safe and easy. I hope if go through some things, and hopefully it gives you some, helps trigger some ideas for you about how you can get started using continuous deployment, or if you're already doing it, some additional things you can do. Whoops. All right. If you haven't heard of Etsy, we are an online marketplace for handmade goods. Last year we did about over $500 million in sales on the site. A few other numbers just to indicate that we're doing this continuous deployment at scale. It's a big business, a lot of volume, and a lot of our members actually use the money they make off the site to pay their mortgage, to cover their monthly expenses. So they really depend on us to have the site up and working well for the buyers, so that when the buyer comes to buy something, that money gets sent to the sellers. I'd like to start with an axiom, which is architecture is relative. If you look at the history of Etsy, starting in 2005 up till now, if we had kept our design and infrastructure that we had in 2005, we never would have made it. It would have been we wouldn't have scaled. We have way too many users now. It wouldn't have held up. Likewise, our architecture now would not have been appropriate back in 2005. We would have spent all our time worrying about scaling for users we didn't have, and not enough time building the features that made us popular to begin with. So here's a not-to-scale diagram of Etsy's architecture. More or less, the design kind of grew along with the business. As we expanded as needed, this is basically how most of us do it. But there's often a lot of talk of, oh, well, it wasn't designed very well in the olden days. When we talk about our systems now, there's like, oh, this crap, we didn't like it. Why did they do that? Well, they did it for this reason. And let's look at the counterexample. Say in 2005, we had said, you know what? We know exactly what we're going to need in 2012. Let's build that. It'll be perfect. And by some amazing stroke of luck, back in 2005, they foresaw exactly, and they nailed it. So now they have exactly what we need today. We're good, right? We're done. Now what? 5 years out, what we have today is not going to hold up for another 5 years. So the implication is that change in the architecture is inherent to the company. It's inherent to time passing. The company changes, all these things, the scale, the product, technology, the engineering team, they all change. And what that means is that we can't escape it. The correct architecture for a system has to change along with it. And so what we need to do is figure out how to do that change well, how to make it successful. This is not successful, right? We want to do better than that. We want to be able to take these big architectural changes and break them into small bits that are safe, that we're confident in, and that aren't going to cause disasters. All right, so let's go back and look at how we got here a little bit. Back in the olden days, or as some of us call it, the 1980s, when you were deploying software, you had to write it, get it all done, and then copy it to all these floppy disks, and take all the floppy disks and put them in a box, and take all the boxes and send them out to stores. And then at the store, someone would come along and buy it. If you didn't get that right, you were done. Like, there was no, oh, well, just go download the patch, because there was no way to do that. You were stuck. So you had to spend a lot of time up front testing the software, making sure it was right, because as soon as it went into that box, it was gone. Understandably, deploys were rare, right? And then this happened. Now, for example, Windows Update, you could just say, oh, we checked, and there's a new version of the software. It's better. It's got fixes. You should download it and install it. It'll be better. Similarly, we also started taking these applications that used to be a thick client that you had to copy and install to your computer and moving them to the browser. So the code was running in the web, right? Just moving data back and forth. Still, though, we were kind of using the old deployment model. We're still using, like, test everything up front, make sure it's exactly right when we deploy in the next 6 months. But, you know, some people said, hey, this is a website. We can deploy this more often. Let's do it every month, every week. But why can't we just keep going, right? Just keep deploying more and more and more. And we can. We can take the unit of measurement from days per deploy and invert it so that now it's deploys per day. All right, so here's what I'm going to talk about. So continuous deployment really lets us reduce failure time, and I'll talk about what that means. If you're getting started, it's more of a cultural shift than a technology shift. That said, tools definitely help. They make things easier, make it work better. But the big payoff, ultimately, is that we can take those big infrastructure changes that wouldn't be feasible in a big bang scheduled release, and we can break them down into small pieces and make them easy and safe and doable in a way that they might not otherwise have been. All right, so let's look at failure and look at the hypothetical case of a project that we're working on, and there's 6 bugs that we put into the code during the course of development. In the case of the monthly deploys, we do a lot of testing up front, and we catch 4 of the bugs. But you know, you never catch all of the bugs, so 2 of them still get through. And they're deployed out to production. We see them. The fix isn't too hard, so we can get that ready, but then we have to go through and schedule a new deploy, get approval from various people, and get the deploy out the next day. So it's out there. The fix goes out in 24 hours. Now the case of continuous deployment. We're still doing testing, and we catch 2 of the bugs, but we haven't spent quite as much time doing testing, so there's 4 bugs now that we don't catch. But because the deployment process is set up that we can just deploy them, as soon as we have the fix ready, we push the deploy out. So the bugs are only live for 6 hours. So now we look at the total failure time. And 2 bugs times 24 hours is 48 bug hours. 4 bugs for 6 hours is 24 bug hours. So even though there were more bugs, the total time of bugs on the system was less. And that's what continuous deployment is really trying to do. It's trying to minimize the total time that there are bugs on the system, minimize the bug hours. This is really a MTTR versus MTTF comparison. When you're talking about when you can't deploy frequently, you want to minimize maximize your time to fail. But with continuous deployment, and mostly with the web cases, we want to be able to recover quickly. That's the case where a customer says, yes, I want this bug fixed. OK, we want to fix it too. We want to be able to fix it as soon as possible. What that implies, though, is a low cost to recovery. So broke down some of the recovery types here and their costs, relative costs. So Photons, that's a display bug. IE7 is a photon bug, right? The arrangement is wrong, the CSS isn't right. Fixing this, though, is minimal. You find the fix, you push it out to production, and sort of all history of the error disappears. Next time the person loads the page, it's working. Electrons is sort of, we put an electron in the wrong place. We put the wrong electrons on the database. These costs are still relatively low. We can, if you have to, if there's a data failure or a mistake written in data, you can generally go back and fix it. Protons and neutrons, now the cost starts to get higher. Now this is in the physical world, right? So example, if you build a road and you build it in the wrong place, that's a high-cost fix. You can't just go through and run a script to move the road to where you wanted it. Now we come to humans. The cost here has gone even more. It's prohibitive. It's unacceptable. right? In 1973, the cost to recover a man named Steve Austin was $6 million. In today's money, that's $31 million. We don't want to, every time we have a failure that costs, we have to recover a human, we don't want to be spending $31 million. That's not a way to run a business. All right, so that means there are a few good excuses for where continuous deployment may not be a good fit. And that is, first example is infrequent changes. If you're only changing the site or the software twice a year, doesn't really help you if you can deploy it three times a day. That's not going to be a good payoff. Likewise, infrequent executions. If you're only running it, say it's a tax program, and you run it a couple times during tax season, then the rest of the year it sits idle. It may not be a good candidate for continuous deployment. Life and death cases. If someone's health depends on the output of your system, may not be a good case because that's where the recovery cost really goes up, and you're not going to want to use the cost of each individual bug is high, even if the recovery may be quick. Again, physical investment. If you're taking the output of your software and you're doing a big physical investment, say you have a 3D printer and you're going to be printing do a run of 100 million widgets off the output of your software, may not be a good candidate for continuous deployment because you don't want to print that 100,000 widgets and then say, oh, it was wrong. Now we got to do it all over again. All right, so an MRI device, not a good candidate. You don't want to be people not getting diagnosed correctly, misdiagnosed because of that. So not a good candidate. NASA, high physical investment, the highest, right? Billions of dollars for a project. You don't want your spaceship to blow up because there was a small bug. So it's really worth putting in the time to test and make sure you've got out all the bugs before. Now, of course, NASA used to be a life and death case also. We no longer have a manned space program, so it's only physical investment. Hopefully one day that will change again. Enterprise software. Definitely a good candidate for continuous deployment. A lot of times when I talk to people, they're like, oh, we're enterprise, you guys are consumer facing, you can do that kind of stuff. People are paying us for our software, we can't have bugs in it. Ask your customers how long they want to wait for a bug fix. Most of them are going to say, I don't want to wait at all. Fix it now. Why do I have to wait 2 weeks for your next release? So that's really the shift that takes place, is you have to look at it and say, we want to be able to fix things as soon as possible because if you're looking at it from the context of we can fix all the bugs before release, then it makes sense to do a monthly deployment and put in all that time and cost for doing all that testing before the release. If you're looking at it from the context of admitting to yourself that, no, we're never going to fix all the bugs before release, then you can say, all right, well, let's work on really optimizing how fast we can fix the bugs that are out. And that's really the shift in thinking that comes into play here. Here's another case. Say your software prints out health insurance cards. Say you're doing a run of 100,000 health insurance cards. That's another case where it may not be suitable to do continuous deployment because you don't want to reprint all those cards because you mix up the first and last name or something. iPhone apps. These are a special case, right? Not really suitable for continuous deployment because if you upgrade your software 3 times a day and Apple only accepts it like once a month or whatever, it doesn't help you. So this is an interesting case where the closed platform is really the restricting factor here more than anything else. Another case that people often say is, well, payments, financial transactions, credit card payments, can't do continuous deployment with that. And the answer is yes, we can. We do. Earlier this year, we've always taken payments, right? We're an e-commerce site. And earlier this year, we started actually processing credit card transactions. We're PCI compliant. And just because you can change something doesn't mean you have to change it every day. So for our payments software, our credit card processing code, we don't change that nearly as often. We get it working and we say, okay, let's leave that. And we treat it differently. So if there is a change to that software, then it gets a lot more review, a lot more testing before it goes live. Because it is a different kind of software. There's a lot less tolerance for a bug here than there is for a bug in our activity feeds display. And that's where the human judgment comes into play, as opposed to saying everything needs a month's worth of testing. We say we know how much testing something needs. In some cases, it may need more, and we may need to give it a lot more care on the way out. Other cases, the impact of the bug is much lower, and we can move a little faster with it. So if you're not doing continuous deployment and you're looking to get started, a lot of questions I get are sort of intimidation about the tooling and stuff. That's not the big challenge. The big challenge is, as in most software problems, the hardest part is us, is making the cultural shift to say, okay, we're going to do this differently. Because the software is not the hard part. It's just SSH and a few other tools to actually do move the bits around as necessary. So the first cultural change is throw out the deploy schedule. The deploy schedule holds us back. If it takes 4 or 5 hours to do a deploy, and you're only doing it once a month, you can say, it sucks, but it's only once a month. We can deal with that. If it takes 4 or 5 hours to do a deploy, and you try to do 3 deploys a day, suddenly now that sucks. So now that takes, the schedule sort of says, well, it's not a problem. We get rid of the schedule, and suddenly now it's a problem. And now it puts pressure on us to say, this tooling isn't good enough. We need to improve it. We need to add more monitoring or more whatever other tool we have. Since we get rid of the schedule, we just ship changes whenever they're tested and ready. So we have a change. It looks good. We've tested it. Let's ship it. Let's do it. That's the main criteria at Etsy for when we do a deploy. Oftentimes, we have a lot of developers, so oftentimes we'll have multiple people who have changes that are tested and ready. So we'll have 4, 5, 8 people pushing in one change, one deployment. Now, there's another criteria that we have for pushing, and that is that the software is stable and tested. If we're having a problem on the site, we shut down all deploys except for anything that's going to fix the problem. All right, so we want to test the software to the site to be healthy and in a good state. Also, supported means that there's people around. You're not pushing by yourself, because in case something goes wrong, you want to have other people who can help you resolve it if necessary. What that means for us is business hours. It used to be that we would the push queue was kind of open 7 a.m. to 7 p.m. Eastern time. Now we're starting to have more developers on the on the West Coast, and so we've shifted that to 7 a.m. Eastern time to 7 p.m. Pacific time. So we've added an extra 3 hours for the people who are working on the West Coast to get their changes in. All right, so what are the tools that we use? Simple one is Jenkins. I'm sure a lot of people use that or something similar. Unit tests, functional tests, definitely standard stuff. We also do a lot of manual testing. We don't have the mythical 100% test coverage. I don't know if anyone else does. I've never seen it. This actually, continuous deployment really helps this, because this is a case where, again, the human problem comes in, and we don't always write unit tests and functional tests when we should. So, and you can kind of get away with it when you're deploying once a month, because it's a pain, but I can do it once a month. I can deal with it. If you're deploying the same feature 3 times for the 3rd time that day, and you're doing manual testing, suddenly, putting a unit test in there to test that, or a functional test, starts to seem more like it's worth it. And you start to think, okay, I'm going to do that because I'm sick of this. Nagios and Naglite as the dashboard. That's on GitHub if you want to take a look. Another tool that we use, tail and grep. This was actually our our CEO wrote a script called SuperGrip. That was just a bash script that combined these two. Tail a bunch of logs, and then use grep to filter out the noise so that we can just look at what are the relevant bits. It's a really powerful tool and one of the primary tools that people are looking at when they're doing deploys now. We've actually ported it to similar thing to Node.js, so there's a web version of this, but I still use the command line because it's way better. And the point, so grep and Enter the Dragon are both from 1973. So the point here is, just because something's old doesn't mean it's not still good and still useful. TA, exactly, right? We should look into using that. Here's another tool that a lot of people have probably heard of, DeployInator. This is just a web interface to our deploy scripts. And what's really powerful about it is it filters out all the thought and things you have to think about for actually how you do the deploy, and really lets you just focus on what you're deploying. And is it going out? Is it working right? You don't have to worry, did the deploy work? Because DeployInator is handling all that. And so it's very simple. It's just, there's 3 buttons, build and test, deploy to staging, and then deploy to production. So you don't have to think about, am I doing this right? It's just, am I doing it? You can't really do it wrong. And that's a really great feature. So when you're going through doing the deploy, there are no mistakes to make. You just, unless you click on the white space somewhere over there, right? That's the low impact mistake. Whoa. Jumped ahead there. And there's also, we have graphs in there, so you can look and see, I want to see what was deployed at 6:14 on Tuesday. And you can go through and look at the logs and see what the diff was, see who did it, see who was involved. So that's a really powerful feature. Now, you may use DeployInator. It's on GitHub. You may use it. You have something else in place of it. Even if it's just a script on a box that goes out to all the other boxes and does stuff. You have a script called deploy the site. Just run that script, and then you don't have to worry about the individual steps of doing the deploy, because it's always the same. So like I said, we have a lot of people deploying, and it gets busy. So we use an IRC topic, channel topic, to organize it. So you go into our push channel at Etsy, and we actually have a bot that manages the IRC topic now. And you type .join, and it just puts you at the end of the queue. And then when it comes your turn in the queue, it'll just announce in IRC, hey, Matt G, it's your turn, go. So then I jump in, load up DeployInator, and start doing the build. Again, it's a low-tech solution that works. Sometimes we could have built something more complicated, but IRC worked, and that's what we stuck with. Graphs are big, right? Everyone loves graphs. Ganglia, graphite. If you don't use Ganglia, it's kind of cool because it shows the individual servers, if that's important. It's a little more hard to deal with mixing up graphs and making dashboards and stuff. Graphite, for example, is a lot easier to make dashboards with. You can mash up the graphs and run functions on the graphs. So that's very interesting. Helps you make the visualizations a lot more effective and easy to read. The big thing that we have on our graphs is this event overlay. So you can see where the graph dips at the far end, there's a vertical line up there. And that vertical line is saying, OK, there was a deploy right then that happened. So I can see a spike in a graph or a dip in a graph and look and see, is there a vertical line? OK, that change was probably the cause of that dip or spike. And then I can use that to trace back and go look in the DeployInator logs. What was the deploy that happened at that time? See who was making the change, talk to them, see what might have caused the spike. Luckily, in this case, that's actually a good change, so we didn't have to go hunting after it. Graphs are great, but you need to get data into the graphs. And one really easy way that we have to get data in is statsd. So statsd is a daemon that runs, and it just accepts UDP messages. And you send the the key for the graphite graph and the metric or just the increment. It sends it out over UDP, and it's good. So it's so simple that it makes the client very simple. There's no state in dealing with connections or anything. So in the code, we just say, statsd timing, query.runtime, 5 milliseconds, or whatever it is. Then you can say statsd increment, query.failure. And that just bumps the graph up. Every time it happens, it bumps the graph up. And so you can see if suddenly we get a big spike in query failures on the graph, we'll see a big spike on it there. And this is on GitHub, so you can check that out. This is really nice. It's easy to install and easy to use. Another tool that we have that I really like is Logster. Logster is great because it just looks at the logs you already have, and then you write a plugin for the logs you already have in whatever format they are. And the plugin converts the log line into structured data that it then sends back to Logster and goes to Graphite or Ganglia. So what's so great about it is you don't have to mess with your code. You don't have to add additional logging or anything. You take the data that's already there that you're just rotating through on your logs, and now you can turn that into graphs that are meaningful for performance or errors or whatever else that would be useful for to see on your dashboards. All right, again, this is also on GitHub. So a couple practices at Etsy that are very useful: feature flags and customer communication. So feature flags are great because it separates the deploy, the copying the bits, from the product launch. When we were doing our credit cards launch earlier this year, we were able to get that on production and have it only visible to Etsy employees. So we could test it on production. We were making actual purchases on the site before any of our regular users could see it, and make sure that it all worked. And then it also let us time the launch for when the rest of the company was ready with the marketing materials and everything else. So it separates those two, and that's very helpful. So what that means is when you're doing a dark launch, you take a function that's, for example, get payment link, and this returns whatever it used to return. And we just change it to say, if enabled credit cards, return credit card link, else return check link. So it used to be returning the check link, and now if you're enabled, it'll return the new link to the credit card payments. And so the config looks more or less like this. We actually use PHP arrays, a big file full of PHP arrays, but generally the point is it's just structured data. So in this case, YAML. And credit cards equals admin. That means that it's on for only Etsy employees, so only we can see it. Everyone else will still be going to the old links. Now we're ready to start ramping up to regular users, and we shift it to 1%. So this is good because only 1% of our users will actually see the new feature. If there's a problem, it's only going to affect those people. It's not going to affect all 18 million of our users. And so when you log in, it looks at the config and it says, all right, are you in the 1%? No, yes. And then it keeps track of that. So when you come back, you're always staying in that group. Then we go up to 5%, and oh, looks like we saw a display error. So we're going to turn it back off, only for Etsy employees, and fix that, push that out, and then resume the ramp up. So now we go back up to 5%, 25%, and ultimately all the way on. So once we're on, we can go through, take the checks out of the code, take the configuration out of the configuration file, and we've switched over to the new system. You can also apply this to A/B testing. It's really good. So it can prove the success of interface changes, design changes, which design may work better, which may lead to more conversions. And then so you put them into one group or the other, and then you look at the outcomes and say, this increases sales by 3%, or whatever it is. It also lets you prove interest in new features. So we have a feature called prototypes. which is similar to Google Labs or some other self-selecting mechanism that other sites have. So you can log in, and if you're an early adopter, you can say, you know what, this looks like a neat feature. I want to join that group. I want to see that feature. If you're not an early adopter and you like to sort of wait, you don't join and you don't see the new feature. And that lets us see, is this new feature something we want to pursue? Is it good? Are there problems with it that we want to resolve before we turn it on for everyone? Is it just not successful at all? Do we want to get rid of it and abandon the idea? So that's very, very helpful and helps us guide where we want to take the product. Now, another one is community communication. So Etsy has a very passionate community, and part of that is because we communicate with them so much. Most of it is through the forums and the message boards. And this is kind of it's an old school system, but it works. And it lets users, we use it to communicate to users, but we also use it mostly to let users communicate to us. So if there's a problem with a particular browser, we may find out about it through the forums. Or if there's a problem that's affecting a particular geographic region, that's another thing that we might find out in the forums. Now, it also creates a great feedback loop between the members, our users, and the engineering team. Because someone may report a bug in the morning, and then in our customer service, they'll see it, and they'll send it to me and say, hey, it looks like this is a real issue. I look at it, I say, OK, here's the fix, push it out, and then jump in the forums and say, hey, everyone, sorry, it's fixed. And this all happens in the matter of hours. So the turnaround time can be really, really small, and it's very satisfying to be able to get those fixes out and get people seeing them so quickly. Another tool that we have is etsystatus.com. This is a WordPress blog that we have. And so if there is a problem with the site goes down, we use this to tell people, yes, we know there's a problem, we're working on it. Here's the ETA if we know it, and ultimately we say, OK, it's resolved at this time. You should be expecting everything to be working again now. The same thing, we have a corresponding account on Twitter, so people can follow us there. It's handy to have two, just in case something doesn't work. All these tools, though, I mean, they're tools, but what they're doing is it's coming back to the culture. We're taking deployment and saying, all right, this is a real product. We're going to treat it like a real product, not just sort of something we have to deal with every now and then. We're saying this is now a first-class member of the system. We're treating it like a product just as we would business intelligence for the analytics groups or administration tools for customer support. We're developers. We're users too. We want to be able to be effective in the work that we're doing. So it's really a cultural shift, and it works to help us. All right. So what does this let us do, though, right? So here's a couple examples from Etsy. First, the photos system. We ported it from twisted Python to PHP, and this is more of a code case. And then the Postgres, we're currently moving our data from Postgres to MySQL shards, which is an enormous change. So this is more of a code case. Our photo system is, it's how our sellers connect with our buyers, really. It's how they say, OK, here's what I have to sell. And how our buyers look and say, is this the right color? Does this look pretty? Is this the kind of sweater I want to have? So, and we get about 400,000 image uploads per day. So this is a really busy system. We can't just take it down and repair it. We have to do the change while the site's live and not interrupt our interaction with the buyers and sellers. So the first step then is we run Apache and PHP on a new port. It's not doing anything yet, but it's there. And then we just take one of the endpoints off of the twisted service and re-implement it in PHP. So far, nobody's seeing it, so we can test it, we can iterate on it, make sure it's working. Once we know it's working, now we can ramp up users to the new service. And that's, again, in small steps, so 1%, 5%, just so we can see if there's any problems and very quickly roll back. This makes it a very safe step change to make because it is so easy to roll back. And once we've done the first one, we just go through and for each of the other endpoints, fix those. Finally, everyone's off twisted, and that's what we were looking for. So now we can just shut it down. We don't have to deploy it. We don't have to operate it anymore. And that's our payoff. All right, so the Postgres to MySQL. We have a big Postgres database in the center of our system. It's completely integrated with everything. There's no way we could have done this in one big release. It had to be small steps, or we just wouldn't have been able to do it, at least without taking the site down for like days. All right, so we start off just doing one table at a time. We don't try to do all the tables, just one table at a time. And the first step is to tee the writes so that writes are going to both MySQL and Postgres. That's only for new writes. So all the old stuff that was still on Postgres, we have to now copy over to MySQL. And we need to make sure that the data matches. This is like the system of record for Etsy.com, so we have to make sure everything's good. Once we're sure it's good, all these other steps that were happening up till now did not affect users. So if we got it wrong, we had time to fix it. We could go back and rerun the copy or change the T writes, make the data fixes that we had to, because nobody was seeing it. It's only now that we're actually starting to ramp up reads that the users will see it, and we'll see if there's any data that doesn't match or if there's any issues with the changes. Because we're doing the configuration ramp up, our configuration deploy is very quick. It only takes a few minutes to deploy a configuration change to all of our servers. So if there is a problem, we can fix it very quickly. And this makes it what would be a huge change. It's a very small percentage of our users are seeing it, and on one table. And so we're taking this big change and doing one small step. Ultimately, once we get all the users reading from the new table, we can stop writing to that table on Postgres. And instead, we can start, stop writing to it, and then that data is now old. We can drop the tables and recover the space on the disk if we need to. And that's done. And then we just repeat this again for all the tables. And we're not done with this entirely. We're certainly more than halfway. I don't know exactly how far through it we are, but we've been working on it for a long time, and we have a ways to go yet. But what's good is that the system's always up. We're never in a state of big risk of, oh man, I hope nothing falls apart on this, because we are making such small changes. So the pattern here is make the changes in small steps. This is just like everything else we do with software. If we have a big program that we want to write, we don't write it in one file. We split it up into different modules. We want to do the same thing with deployments. And dark launch via config. You don't have to launch anything, actually. You just launch a placeholder that is just sitting there, and no one's going to see it, but you can go through and see it. And then what that lets you do is iterate on the new feature, the new system, the new infrastructure. Iterate on it while it's dark until you're happy with how it is. All this time, you have plenty of leeway to get it wrong because users aren't looking at it. And you only have to turn it back on. So then we maintain the old and new in parallel. And this is a really powerful idea because when you have the old and new, you can switch back and forth at will. You don't have to worry about the big problem with a lot of changes is what happens if it doesn't work? What's our rollback plan going to be? Well, here the rollback plan is dead simple. It's super easy, and we have absolute confidence that it's going to work. So that's what really makes this change, these kinds of changes easy to do. And ultimately, slowly ramp up to the new architecture. And the big payoff, of course, especially if you're replacing something that's been unpleasant or causing a lot of problems in the system, is wiping it out, deleting it. Deleting it from the code base, all this stuff is so fun, I have to tell you. All right, so once again, we want to minimize the bug hours, trash the schedule, iterate on the tools, and make the big changes that we've been looking at and that we've been scared to because the risk is so high. We can take the risk out, and we can do them. I'd like to close with a tweet. This is from Ian Malpass, one of our colleagues at Etsy. The major problem with continuous deployment is that once you've used it, it's difficult to consider working for any company that doesn't. This is absolutely true. Anyone who's used it, you know. If you haven't, try it. It's the MTTA there is mean time to addiction. For continuous deployment, it's hours. At Etsy, we have everyone come, and on their first day, we try to have everyone deploy to production on their first day. And if you don't get hooked on that one, then your next deploy is gonna get you. So it's really a satisfying way to work. And if you ever want to try it, come by Etsy. We'll let you deploy Etsy.com to production. Come see me. We work in Brooklyn, and that's all I've got, so thank you. Yeah, questions?
Yeah, so you mentioned Leisure Suit Larry putting software in the box. That's really cool, and it sounds a whole lot like the Apple App Store, which you also mentioned. Just wondering if you had any advice on handling continuous deployments with mobile applications.
Sorry, can you handling what?
Is this on?
Yeah.
Okay. No, you had mentioned Leisure Suit Larry, software in a box, and all that, and it sounds to me a lot like the Apple App Store, which you also talked about. Do you have any advice for doing continuous deployment and how that fits into a mobile app development team?
Well, if anyone has an Android phone, they deploy a lot more frequently than Apple certainly does. And there's a balance, really, with how often you want to deploy something. I'm speaking of it more for a user, from a user's perspective, than doing it. We don't have an Android app, but there's a balance between annoying people with having to do downloads, because it's not like a web browser where you just load up your browser and you get the new version of the code. You do have to actively click on it. It's similar to Adobe. I don't know if I want to say this. It seems like every time I install Adobe PDF, it gets a little bit worse. So you don't want to do that. But it's definitely a balance. But you want to be able to make changes, especially if it's a high priority fix or a very important change. You want to be able to make that change and get it out. And the other case there is you're depending on the user to actually do the update. So you have to be more aware of backwards compatibility if you're using a service that, someone may not update their app for 3 weeks, and do you still want them to be able to use the service, or do you want to break them and say, look, you have to upgrade? So that's an interesting.
So you mentioned that you guys are gradually switching from Postgres to MySQL. What motivated that change?
I'm going to punt on this a little bit. I don't want to get too caught up into Postgres versus MySQL. That change was already underway when I started. And I think it had a lot to do with some of the technical leaders at Etsy, John Allspaw and Kellen, who were from Flickr. They were more familiar with MySQL operationally and functionally. And we had to go to a sharded architecture, so we had to switch anyway. And that, and along with the master-master replication, I think, is the primary things. But yeah, I'm kind of going to punt.
Can you speak to how being PCI compliant might slow your continuous delivery, and what steps you've done to stay compliant?
Yeah, so our PCI environment it's in a separate cage. It's totally separated from the rest of our environment. And so when we do the deploys to that system, there's a totally different process that we have to go through. You have to get more approval. It is more of a hassle because that's part of what PCI is about, is making it harder to change things. And certainly harder to change it without, the right plenty of people knowing about it and approving it. So it's a slower process. It takes longer, and more people are involved. But we still have it set up so that when we need to make a change, we can make it. And we're not dependent on a schedule to say, oh, well, our next deploy to that is Thursday, so we're going to wait until then.
You guys are a PHP shop. What are your thoughts on being able to do continuous deploy for shops that are using compiled languages like Java? Is it possible?
Absolutely. We use Solr for our search stack, and that's Java, and we deploy that the same way. So PHP, the difference between PHP and Java is that you're compiling it after you push the code out as opposed to before you push the code out. But you're still just pushing out code. It's either in compiled format or not. And so that's just shifting the step and putting an extra step before you do the deploy to say, all right, compile this out and then push the code. But it's definitely feasible.
You had a slide about 6 bugs and catching 2 and then fixing 4. The question I wanted to know was what happens when one of those fixes causes another bug, and those bugs cause other bugs, and one of those eventually causes a critical bug, which had you done a little bit more testing up front, you would have found that.
I guess I would say that I'll put it back and say, what about on the 2 bugs in the monthly release when you push that fix out? And that push causes another bug, and now you've got to wait another day to push the fix for that. I don't think that part of it really changes. I would argue that part doesn't change, that you're still going through the development process, and you're just as likely to introduce a new bug through the other change. And from my perspective, it's always better to be able to fix the bug fast. But
I think my point is more that you can end up in a situation where you actually harm the user. When you take your Postgres migration as an example, let's say there's a job that runs once a year, and you finish your migration, and then the stored procedure doesn't work anymore because of the editing Postgres database, and the stored procedure fails.
yes, that is a case. But again, I think that doesn't. The case you say could just as easily happen with a monthly release if it's running once a year, for example. If it's,
I'm not disputing that. The question is, what do you do in order to resolve those kinds of things?
and okay, well, you fix it, right? The same thing you have to do. Otherwise, maybe I'm misunderstanding the question. You can ask me later, but yes, absolutely. And I can say when we're doing a deploy and there's 5 people pushing their changes out and there's a bug that's introduced, it's hard enough finding what caused the change or the failure just from those 5 people over a period of with like an hour's worth of changes. So if we're going for a month, now you got to find it's making the haystack bigger when you're trying to find the needle. But like you said, you can introduce changes. Changes are going to introduce failures. You just have to fix them, you know. Yeah.
I'm curious if you guys have developed any strategies for keeping test environments in sync with production when you're pushing code that often.
Oh man, nothing like amazing, right? We have the databases with the same schemas on that we have on production, but our dev data is not great. We do have our dev tools team is working on that right now about how to get better dev access. One thing that we've done that's pretty interesting is we have a read-only proxy, so that if you're working on a bug that's read-only, you can set up the proxy to connect through to production so that you can actually see the issue on the production data from your dev system. So that's very helpful. But yeah, in terms of actually, we have had a few things that we've looked at, but nothing. It's not a solved problem for us.
I personally have a question, actually.
All right.
It's a sort of a dev-oriented question about feature flags. You mentioned that basically there's a large PHP file showing the configuration of which should be, which feature should be enabled or which group should be targeting it. But behind that, the code itself has to have branching in code to handle that, right?
Yes.
And my question is basically, how do you handle that over time? Like, once a feature has been deprecated, for example, you've switched to a new way of doing payments, but they're still existent in the code, the old way of doing payments, and it's no longer reachable. There's no pressure on development necessarily to remove that, and so that cruft could just remain. How does Etsy handle that?
This again is another one of those human problems. Right now, we actually have a project. We're heading into the holidays, which is our busy period, and we're doing some work to go through, hunt down those unused feature flags, and wipe them out. It's hard. There are some features that kind of those if checks linger longer than they should, and it's a question of discipline and time pressure and just all the sort of software engineering issues that we always have. But we do have some stuff linger, but for the most part, we try to wipe it out. There's a question in the back.
Just kind of a point on the whole idea of the feature flag. The benefit, though, is you now know where the cruft is. The opposite of that is the reality that in many cases when you don't have feature flags, you just have cruft. With feature flags, you have this well-defined if statement that you can now go and just delete that section of code because you know it no longer ever gets executed. Or, once again, the metric idea, you can actually go and measure whether or not that was executed if you were really that concerned about segments of code. So,
yeah, absolutely. And there have definitely been cases where I'm looking into some code for some other purpose, and I come across a feature flag that I think, you know what, I'm pretty sure that's old. I don't think we need that anymore. And then I go talk to the developer of that feature, and he says, oh, yeah, I forgot to take that out. And then I can just go through, and at that time, we know it's solid, so it's a very easy change to delete the feature flag, check, delete the else block, and go through, use grep to find all the other instances of that. And then you can just sort of wipe it out in one go with pretty confident, high level of confidence.
This will have to be our last one for time.
Sure.
yeah, I know, but they might want it for tape. So I've worked with companies that have thought about this process, and the thing that always has seemed more difficult from their end, from the business side, is how do you break the problem down into small enough chunks to minimize the risk and be able to do, you've got the feature flags where you could turn a whole feature on, but at what granularity are you breaking down the work and pushing it out into the world, even if it's just from an admin, viewable from an admin side? And how much, Etsy obviously kind of a special case because you've got, it's technology all the way up as opposed to turtles all the way down. But how do you run into conflicts with the business where they're like, do this in 36 months worth of work and just hand it to us as one big lump. Which seems to be, here's our 5-year plan, technology, go execute it. Which seems to be kind of the standard business model, which of course doesn't work with Agile or continuous deployment or anything if you're looking at that. What has your experience been, or what have you heard from other people who have been successful with this?
Yeah, so that's one thing that I didn't talk about that too much, but for first the granularity. We just sort of use judgment about the change. If it's the kind of thing where we want to be able to iterate on it, it needs a feature flag, right? So you want to iterate on it while it's dark. If it's a smaller change, certainly not every change gets its own feature flag. We may just say, okay, this is a pretty simple change. I'm going to go ahead and do it, test it, and make sure it works. So there's just a judgment factor on the risk and what, how long you expect that change to be in flight. As far as the granularity. As far as the product, that's one thing that's really great about our Etsy product team is they think about the product in terms of a progression and in terms of how the product is going to iterate, not just like, all right, we want this, come back to me in 6 months. At my last company, we were doing Agile from a development perspective, but the product design side, the product side, was still doing that kind of come back to me in 6 months or a year with this big stack of software specification. And so that we were giving up the opportunity to iterate. One thing that I think happens with continuous deployment is now you're putting this onto production so that the product people can see it changing day by day by day. And now, I haven't seen this happen at Etsy, but my expectation is that when a product person sees that, suddenly they start to get the thinking like, oh, actually, you know what, let's change this other thing a little bit. And then my hope would be that seeing it change on a daily basis, they would kind of come up with their own iterations and realize that whatever they may have said three months ago as far as what they want isn't what they want anymore, and start to think more iteratively about it. But again, I haven't seen that happen. When I started at Etsy, we were already thinking of the products pretty iteratively. So, all right, I guess that's it. Thank you, everyone.